Let's take a look at the Cynefin framework. Cynefin is more than just an odd Welsh word. Its literal translation is habitat or place, basically your home, your place of belonging. A closer translation is place of multiple belongings, as it takes into account several factors, including your religious background, cultural and geographic location, to make up a sense of where you belong. This set of complex, interwoven contexts makes it a very good name for this framework. So what is the Cynefin framework? Well, the first thing it's not is a categorization model. A categorization model is generally something used to work out what something is. These frameworks usually take the form of a quadrant model with two variables, the idea being that you place the items being categorized into one of the four boxes based on their relationship to the two variables. The Cynefin framework is a sense-making model that's used to make sense of where you are within a given context. Because this framework is derived from data taken from your context, the framework is established by passing data through some form of social process. This is different to a categorization model, where the framework, which is an absolute, receives data to be categorized. As this framework is driven by data, the framework will need to be reset from time to time as the data and context change. The underpinnings of the framework are based on there being three basic systems: complex systems, ordered systems, and chaotic systems. If we then split ordered systems into two to introduce complicated systems and clear systems, which are both types of ordered system, and then we introduce a concept of disorder, which is the void at the heart of the framework, representing the absence of any system at all. All that gives you the Cynefin framework. If we lay these systems out, we have complicated systems, clear systems, which are both types of ordered system, complex systems, and chaotic systems. Taking the clear domain first, this is an ordered system where predictable cause and effect relationships exist, meaning they can be determined in advance and are repeatable. The relationships between cause and effect in this domain are self-evident. As a result, the decision model is sense, categorize, and respond. We can categorize in this case because we can predict what the cause and effect relationships are. Therefore, we decide based on a predefined set of actions with known results. The predictable nature of these actions mean it is a list of applicable best practice. The complicated domain. This is another ordered system. Cause and effect relationships do exist, but they are not self-evident. This means a right answer exists, but requires either an analytical method, i.e. sense, analyze, respond, to analyze the problem, or bring in a domain expert. We apply good practice in a complicated domain because several different approaches and practices can be used to solve the problem, all of them perfectly legitimate, as long as you have the expertise to back them up. Forcing best practice on those who know what they're doing will at best cause friction and at worst cause them not to use best practice when it should be applied. The complex domain. This is a system without causality. The system is born out of light constraints and loose couplings, or where agents change the system. Cause and effect in this case are only ever clear in hindsight. In this case, our decision model is probe, sense, response. We conduct safe-to-fail experiments rather than forcing a fail-safe design. When the experiment succeeds, we amplify the result we want. If an experiment fails, we dampen it. The amplification and dampening strategies for completing experiments and analyzing results should be defined up front. We get emergent order as we practice new ways of working from developing and performing experiments. These practices start out novel and are adopted and used for as long as they are relevant, eventually being replaced by new emergent practices. The chaotic domain. Here, cause and effect relationships cannot be determined. If we found ourselves in this domain accidentally, we move fast to stabilize the situation by whatever means or practice necessary. The model for making decisions in these cases is act, sense, respond. Any practice that emerges is going to be completely novel, applicable to only this scenario. This really is the unknown. This gives us a really easy way of deciding how to work, but only if we take note of requisite applicability. Basically, you should think differently depending on the space you're in. There is not a one-size-fits-all, as promoted by many other management theories. Where do we spend most of our time? Disorder. Disorder is a central diamond in the framework, and that's where we are when we don't know which of the 4 domains we're in. When in trouble, we can then tend to interpret the situation based on a preferred method of action. Too long in a bureaucratic process-based role can result in seeing everything as failure of process, leading to a preferred method of action which fits only the clear domain. Experts, however, will tend to see everything as a failure to provide them with enough time or resources to perform analysis, and this puts their preference for action in the complicated domain. Natural complexity workers, such as battlefield commanders and some politicians, react to a crisis by getting lots of different people from lots of different backgrounds together in a desperate hope that someone will come up with the right solution. This actually is quite a good strategy and is as close to a one-size-fits-all as you can get. The chaotic domain is inhabited by fascists and micromanagers alike. This is because they love a crisis where they get given absolute control and everybody must do what they say. What you get in a normal decision environment is people sat in a disorder space, analysing based on their own preferences. What the Cynefin framework allows you to do is say, this is complex, therefore we should probe. Or this is complicated, which expert should we get involved? Considering the boundaries into the chaotic domain. First, we'll look at the complex to chaotic boundary, which is relatively straightforward. Making an intentional shift into the chaotic domain from complex can be a way of driving innovation and discovery, especially when done as part of a safe-to-fail experiment. In contrast, the clear to chaotic boundary is very different. This is represented by a cliff edge. Entering the chaotic domain unintentionally from any scenario is undesirable and at worst catastrophic. However, The cliff boundary between the clear and chaotic represents a much greater risk. Because you can't climb back up the cliff, well, not easily anyway. Having come from a clear domain suggests you may not have the practice and expertise, making it very difficult to shift into the complex domain. Inappropriately acting using the clear domain for too long through over-complacency is what leads to falling over the cliff edge. Acting based on an incorrect assumption using the clear domain when in fact we should be working in either of the two higher domains, complex or complicated. And that's where most of the management practices should be, by the way. Means it's possible to fall into the chaotic domain with quite catastrophic consequences. Now you understand the Cynefin framework and how it can be broadly applied to many types of situation, system or project. I'd like to dig into how I think this can be applied to software and how some of the pitfalls in the software development can be represented within this framework. Now, to explore the transition over the cliff into the chaotic domain in a software development context. My theory as to why software development goes over the cliff starts with culture, be that culture within the team developing the software or culture in the wider organization. Culture has its own feedback loop and can be a fairly big influence on management styles, practices and attitudes used towards software projects. Project managers can unwittingly roll a project over the cliff by imposing unrealistic timelines that have been born from assumptions based on very flawed and incomplete requirements. This style comes from a dogmatic adherence to waterfall and the sense that there is a one-size-fits-all to do all software projects. Waterfall in itself does fit some types of project. Just none of those involve software development. If this approach is then culturally adopted, maybe due to some early success with small development projects, then you get stuck in this clear domain, where that metaphorical cliff is an impending disaster waiting to happen. Teams with a close focus on just fast, rather than velocity and good practice, find themselves running right over the cliff. This can be the way for greenfield projects, because initial quick successes are not sustainable once code becomes more complicated or even complex. If good practice like clean code, test-driven development, or some other way of mitigating risk of regression isn't adopted early on, any sustained success in this fragile state is short-lived. Some wrongly believe that this is simply a language or platform issue and can be simply solved by shifting to the cloud, but these pitfalls are cultural in nature and entirely programming language and platform agnostic. Doesn't matter if you're programming VB, C, Go, Java, Angular, PHP, Lisp, Swift, .NET, Rust, Node.js, Ruby, Pascal, Clojure, JavaScript, or Python. You can still fall off the cliff and find yourself in the chaotic no man's land with only a debugger for a friend. The complicated domain is the home of good practice, like test-driven development and agile methodologies. Cloud, on-premise, monolithic, microservice, distributed monolith, or any other architecture can live in this domain. With some form of digital transformation or DevOps adoption, we can shift left to the complex domain, home to safe-to-fail experimentation, chaos monkeys, canary releasing, A/B testing, and negative or reverse prototypes. All this is used to give us feedback straight from the coalface of our customers and users. For this reason, the management of development teams and code bases firmly sits within the complex and complicated domains. Adoption of good practice should be done as soon as possible, if not before the first line of code is written. Practices like clean code, test-driven development, and agile methodologies are paramount to the success of software development.